Hi, my name is Eric Gieseke. My project is on a big data case study for mobile analytics. So the goal of the project is to provide a scalable activity data platform, create a scalable platform for the collection and analysis of large volumes of activity data. This device here is a Nike Fuel Band. It's worn on a user's wrist, and it monitors activity data, movement, sleep, other things. That information is transferred from the device to the user's phone, which is then transferred to a cloud storage where it can be accessed by third-party applications like the application defined in this project. So the use cases supported by the system and the actors are defined here. Basically, there's an individual who wears the activity monitor and then shares the data. There's also a group administrator that can define groups for users to join. Examples of groups would include employers or health organizations or maybe a fitness club. And then there's also viewers, people that can have access to the data that can do things with it. For example, employer measuring who's healthy within the organization or not. And then also another actor is the BMA system. It's collecting the activity data, and also it's performing analytics on the data. And so these are the key actors, and then the use cases are defined here. So just to summarize, individuals wear devices and generate the data. Group admins and viewers analyze the activity data, and then the BMA system collects the data and performs the analytics. This is a view of the system architecture. It kind of flows clockwise. Here is the Nike Fuel Band, an example of an activity monitor worn by the individual. That activity device communicates with the user's phone, and then the data is transferred from the phone to a cloud storage area where it can be accessed through an API. The blue area here is the body monitor analytics, or BMA, data collection. This is the system that I'm defining in this project. It's composed of a few subparts. One of them is a data collection service that knows how to reach out to the APIs and collect the data for the users that have registered with the BMA system. That data goes into a big data storage, persistent store. There's another component that does data analytics on the data and generates reports. And then there's a user interface component that has both a mobile and desktop interface for access from viewers and individuals. And here in the bottom, we can kind of see the output, a sample output of what a report might look like. This is showing elevation gain and loss over time, and also average pace over time. And the blue line is the average pace. This is actually taken from Map My Run, but it's an example of something that could be produced by the body monitor analytics system. Okay, the domain model is basically has the individual in it, the body monitor, the device that's recording the data, the activity data that's produced by the device, basically time series data, has a timestamp, a name, and a value. And we have reports that are generated based on the activity data. And then also individuals can be put into groups or composites so that they can be organized in terms of organizations like employers or fitness clubs or health organizations. These objects are what I use to define the tables for the NoSQL store. So technologies, I'm leveraging a NoSQL database for scalable and fast persistence, and the eventual consistency is okay. I don't need the ACID properties of a relational database, but I am more concerned with the scalability and fast read-write access. Also, I want to leverage MapReduce based analytics for scalable processing of the data, and I'd like to use Hive, Pig, Mahout, and also do custom analytics. And it'd be great if this could all be in a single platform to keep the deployment and administration simple. So for the NoSQL database, I chose Cassandra, namely, or because it's simple to deploy and manage, supports multi-site deployments, which is good for fault tolerance, and also it outperforms HBase and MongoDB, as you can see in the chart on the right, where Cassandra is much more performant than either HBase or MongoDB. And this slide is taken from our NoSQL lecture notes. Also, Cassandra is well supported. It's open source, but also has a company called Datastax behind it. So I use the Datastax Enterprise Edition, the deployment of Cassandra. It basically has a certified Cassandra distribution. It has out-of-the-box integration with Hadoop for MapReduce, Pig for scriptable MapReduce, Hive for SQL-like MapReduce, Mahout for machine learning, Solr for search, and Scoop for moving data in and out of the cluster. And then also the MapReduce jobs run directly on the Cassandra cluster and the data. So it's basically one cluster is supporting both the very fast data persistence as well as very scalable analytics support. So Datastax comes with some nice tools that helped in the project. One of them is the a virtual machine that you can download and use to set up Datastax enterprise environment. And so that made it very easy to experiment with basically a single node Cassandra cluster. It also comes with something called the Dev Center, which is an IDE, or integrated development environment for managing Cassandra key spaces and column families. I used it to define my my key space, my BMA key space, and also to define the tables within it, their primary keys, as well as any secondary indexes that I required. Here's a snippet of the script, the SQL script that I used to create the key space. You can see create key space and BMA with the replication information using the replication factor is 1 because it's a single node system that I'm deploying to. It uses the BMA key space and then create the tables and specifying the columns and the primary keys. Datastax also comes with something called the Op Center. It's a basically a console for monitoring the Cassandra cluster. It supports various features like monitoring the reads and writes and latency and disk activity as well as storage capacity. It also comes with extensions to support the Hadoop, monitoring the Hadoop jobs, the job task and tracker from within the console. So that's very handy. So one of the things that comes with the DSE package is the integration with PIG. So you can run PIG jobs directly on the Cassandra cluster. Here you can see the PIG is being started by just saying DSE space PIG. That launches the grunt script, and from here you can access your tables and do scripting with PIG, manipulating the information that's in the Cassandra cluster. The DSE package also comes with Hive. So with Hive, you can run queries, SQL-like queries, directly on the Cassandra tables. This was very seamless and very easy to use, and actually better. I thought that it was much better than the integration with PIG. I could basically do SQL queries right out of the box on the using the key spaces or the table definitions that I had defined within the Cassandra cluster. So here you can see I start up Hive, basically DSE space Hive. I show the tables. I use the correct key space, and then I can show the tables, the activity event, devices, groups, users, and then I can also do queries on those tables. Select star from users. I see 3 users. And I can also say select star from groups, and I see the 2 groups that are defined in the system. And again, all the information is coming from the Cassandra tables underneath. So one of the key points I wanted to be able to do was not only store large volumes of activity data, but also do interesting reports on it that could provide value to the users of the system. Here's a sample report that's basically determining the average sum and count of steps for all users, and I'm sorting by the average number of steps. So basically it's very SQL-like. Select username, average steps, sum steps, count steps from activity event, which stores all the activity events, time series data, group by the user, and order by average steps in descending order, and that'll put the most active users at the top. And you can see the ellipses indicate that some MapReduce activity, and then finally the result is displayed here with the 2 users. So the amount of data that I used was small because I'm working with a single node cluster. So in summary, I leveraged Datastax Enterprise Cassandra distribution. DSE combines Cassandra with Hadoop. Cassandra is scalable and fast, NoSQL data store, good fit for capturing large volumes of activity data. Hadoop with Hive and Mahout provide out-of-the-box analytics on Cassandra and on the cluster as well as the activity data. And it supports required use for large volumes of activity data collection and flexible, scalable analytics. And the DSE Sandbox VM and the associated tools powered a successful POC. So thank you very much. I appreciate you listening, and that's all.